So in this key concepts page, I have some information that lends itself to doing unit conversions. In particular, knowledge summarized by an equation like this one right here, 1 kilometer, that's what that means, km stands for kilometer, is equal to 1,000 meters. And that may be common knowledge, or if it wasn't, now you know that a kilometer is equal to 1,000 meter. And that in the SI system, the prefix kilo pretty much always means 1,000, so a kilogram is also 1,000 grams. That was a little weird though, because the kilogram is actually the base unit and the gram isn't. Sometimes that throws me a little bit, but anyways, but then you also have like the centi prefix, and this is like 1 meter is equal to 100 centimeters. Maybe I could have written this as a centimeter is equal to 1 over 100 meters, or 1/100th meters, or you can even write 10 to the minus 2 meters if you like, to use scientific notation. But in 1 meter is also equal to 1,000 millimeters. Really, there's other ways to write these, but you need something to start with generally to do a unit conversion. And again, I'm hoping these are all kind of familiar. Here's also the relationship between 1 centimeter and a millimeter. Basically, a millimeter is a tenth of a centimeter, so that means there's 10 of them in 1 centimeter. Then there's also the micron or the micrometer, which is this little kind of, this is a Greek letter right here that stands for the micro prefix. And there's 10 to the 6 of those in a meter. And 10 to the 6, I guess that's a million, right? But you could also say that that means that 1 micrometer is equal to 10 to the minus 6 meters. There's also the nanometer, and there's 1 nanometer is equal to 10 to the minus 9 meters, but that means there's 10 to the 9 nanometers in a meter. And that kind of covers the SI length units right there, and with other SI units like mass units kind of come to mind. You can also use like microseconds, nanoseconds, milliseconds even if you want, for time, for example. It's okay to use the minute too in a sense, but that's maybe a little less SI there, not using an SI prefix in other words. But then there's more, I don't know, you could say exotic, but commonplace on the other hand. Most of our everyday lives are things like miles and inches. So knowing this conversion factor that a mile, I'm going to write it down here, a mile is equal to 1.609. Sometimes 1.6 is good enough as a rounded version of this relationship, but I'm going to use 1.609 somewhat habitually to avoid round off error. It's kind of like 4 sig figs to me is like a good standard in that sense, although I guess for the inch, like, right, so that maybe it's worth writing down that the inch is equal to 2.54 centimeters. I think I've looked this one up before and like what definitions it's actually based on. And I think if you went to like one more significant digit, it would basically be as round off to as like 2.540. So that way that makes that one pretty safe. I think saying that 1 hour is equal to 60 minutes is equal to 3,600 seconds, I'm hoping is straightforward. The 3,600, sometimes I've gotten questions about that, but basically since there's 60 seconds in a minute and you already have 60 of them here, 60 times 60 is 3,600. And then there's a bit more of a story that I think is going to come in with the pound, which is a commonly used unit in everyday life. And so that's why I have kind of two things written here. One of them there is saying that the one, maybe I'll just write that, the 1 kilogram is equal to 2.205 pounds. But I put a little asterisk there, and I'm making the claim that that works for the International Avoirdupois pound mass. So it turns out there are some different definitions of the pound that are accepted. There's even like different governmental based definitions. Like I think this is one of the more international ones, but like I think that like the U.S. government and the British government sort of have their own definitions for the pound. I think they're in agreement. You could look that up maybe. But one of the issues that does come up from this is that the pound, it turns out, can either fall under the category of units that describe mass, which is a base unit, but it can also be units that describe force, and force is not a base unit, it's a derived unit, and I'm not going to necessarily digress too much on that because that's going to be more of a story a couple of chapters from now in this class. We're going to be really focused on force and its units, so that'll come back a little bit. But it is worth recognizing that if you are talking about a pound, so this LBF symbol here stands for the pound force unit, and the conversion for that, so I'm going to write that down as well because we might need it in an example, is 4.448 newtons. And the newton, it turns out, is the name for the force unit that is based on base units in the SI system.